Namaste students, my name is JVS Dr. Neeraj Dhulia, Faculty of Agriculture and Veterinary Science, Jyoti Vidyapeeth, Women's University, Jaipur. So today we are going to discuss a topic that is solar distillation. Okay, and this is related with a subject that is renewable energy and green technology. So I think you are aware about the distillation. What is the distillation? So distillation is the process to purify water, and it is the water first it is evaporated, and the vapor of water is condensed and collected, and this condensed water vapor is known as the distilled water. So the solar distillation is the use of solar energy to evaporate water and collect its condensate within the same closed system. So unlike the other forms of water purification, it can turn salt or brackish water into the fresh drinking water. That is the desalination. So the structure that houses or process is known as the solar still. So what is the solar still? Solar is the still is the structure uh, by through which you perform the solar distillation. Okay, and although the size and dimension, material and configuration can vary, all rely on the simple procedure wherein an influence solution enters the system, and the more volatile solvents leave in the effluent, leaving behind the salty solute. So solar distillation differs from other forms of desalination that are more energy intensive, such as methods like the reverse osmosis or simply boiling water due to its use of free energy. So a very common and by far the largest example of solar distillation is the natural water cycle that the earth experiences. Okay, so the rain is the example of the natural distillation. Okay, so what should be the design, or what is the design of the solar distillation system? The fundamental aspect of a solar still have gone unchanged since it is discovered. The simplicity of this design is one or more solar stills are the benefit of its continuity. So however, there are many variations are also available. um, the typical single slope or basin still, and these can fall into one or two categories: the active and passive. Okay, so passive solar steels and active solar steels. So these labels classify the steel by the method that is uses to acquire the energy to drive the evaporation of the water. Passive solar steels, of course, more conventional and have been the only ones discussed up to this point. So active steels, however, can obtain waste heat from the image of sources. A good insulator is necessary to reduce the thermal losses and prolong the evaporation processes even into the night also. The insulation that could be used include things like styrofoam with the polypropylene cover, or wool, and can retain some of its insulation even when wet. So what is the passive solar steels? So conventional solar steels rely solely on the sun to distill the water. However, their complexity could still reach that of active steels. So, if not other more intricate distillation methods, passive steels then vary widely due to this one constant, and can be further organized into subclasses. Some more type of passive solar steels, including the single effect passive solar steel, multi effect passive solar steel, basin, double slope, wick, multi-wick diffusion, and greenhouse passive solar steel. So these are the common type of passive solar steels. So what is the single effect steel? It is simplest and more common, since only one interface is necessary to convey the energy and collect the condensate. An example of crucial design challenge in all solar steels is keeping the distiller airtight. If not airtight, efficiency drops severely. So often a shallow through is used, painted black and fluted. So a slanted pane of glass covering and allowing condensed water vapor to slide down into an output channel. Except 1 gallon per day per square meter of glass. Other approach is molded plastic. Example, the water cone, and this has been advantage that is it can be more easily made airtight, and mass production should make it affordable. Then multi-effect steel, so it required double or effort in regard to ensuring all seals, and could be more too difficult to clean, but they can raise the protection of fresh water significantly. The way by which the water is stored for its time in the liquid phase can also contrast. Next is the basin type steel. It contains the water in an impervious material that is a component of the entire enclosure and are the most ubiquitous. Then wick steels use cloth like material that use the capacity that use the capillary action to propagate the water through the system. And when efficiency and effectiveness are key, wick steels outproduce basin steels due to the greater surface area of the evaporation, lower energy cost to heat the water, and ability to create a much larger effective area for solar radiation to transfer the energy into the water. Next one is the multi wick steel, and obviously play of typical wick steels, and much like the multi-effect premise from above, they generally increase the productivity for increasing the influence surface area exponentially. Then two more types of passive steels are there. One is the diffusion type steel that run with the ideas introduced by the multi effect and wick steels, and a further advancement of both. Perhaps uh, this design behind these efficient steels, which consists of a series of closely spaced parallel partitions in contrast with saline soaked wick, have great potential because of their high productivity and simplicity. Then active solar steels are these. The active solar steelers use additional heat sources to promote the existing thermal process. The foundation of the design of these desalters has already been laid in the discussion. So the source involved with this branch of solar steels will be uh, the CPCs, that is the compound parabolic concentrators, then flat plate collectors, then solar heater, and finally the novel waste heater. So active steels add another element of complexity to the not so complex base design. But once again, this alteration can promote faster and larger quantity of the fresh water generation. So this was all about the solar distillation process and solar distillation system. So hope you are satisfied with this detailed session. If you have any query, you can write in the comment box. And this session is powered by Digital Version 2, Jyoti Vidyapeeth Women's University, Jaipur. Thank you.